All right, we're on to 6.7. This is going to be prepping for coordinate proofs. Okay, we're starting to play with the big boys here. This can be a little bit challenging, so make sure that you note any questions you have and then ask them to me later. The first part here is kind of just a summary of what we've done over the past several sections. Let's talk about the different ways we proved a figure was a parallelogram. Okay, one of the ways is both opposite sides parallel. Another one was both opposite sides congruent, both opposite angles congruent, one pair of opposite sides parallel and congruent. Number 5 was diagonals bisect one another. Now the ways that we proved that a figure was a rectangle was showing that it has a right angle and also showing that the diagonals are congruent. Proving that a figure is a rhombus would be after you've proved that it's a parallelogram, two adjacent sides are congruent. The other one was diagonals are perpendicular. And number 3 was diagonals bisect angles. What we're going to be working at is looking at how to prove the different figures are these special parallelograms on a coordinate plane. I think I told you guys that we have been looking at figures that are not on a coordinate plane. Now what we're going to be doing is we're going to have like a figure like this, and we're going to try to figure out, well, is this thing right here let's say a rhombus or something like that? And we are going to use different formulas and the points on here to be able to do math basically and show that all the sides are congruent or show that the diagonals are congruent or something like that. So what we have to do is we have to think about what formulas we have from Algebra 1 and from geometry and how we would use them. The distance formula, you guys should remember this one. We did this in our class, and we also did it in Algebra 1. It is the karate rabbit. It is the one where it is the square root of x2 minus x1 squared plus y2 minus y1 squared. That shows the distance between two different points. Okay. The midpoint formula was where we went over and just did x1 plus x2 divided by 2. And we had y1 plus y2 divided by 2, and it gave us a point. And the last one is slope formula. That one is from Algebra 1. Now your slope formula is going to be the rise over run. Remember, rise over run. Is rise a change of y or a change of x? Change of y. So it's the y from the second point minus the y from the first over run is a change of x. X from the second point minus x from the first. That's what your slope is. Now you're going to have to think back to Algebra 1 for some of these things. Now, here are some of the things that we can use in a proof. If we were trying to show that things were parallel, do you remember what formula is we use to show things are parallel? Slope. So if you wanted to go over and show things are parallel, aka same slope. Now let's say we wanted to look at opposite sides being congruent. Which one of those formulas would show that opposite sides are congruent? Distance formula. Sides being congruent. Now let's say we want to show angles were congruent. Can't really do that. If it was showing both of the angles were right angles and they're congruent, then that's one thing, but we're not going to really be showing opposite angles are congruent in these type of proofs. One pair of opposite sides is parallel. We already told you that that is the slope formula, and congruent, we already talked about that being the distance formula. Now, this one's kind of tricky. How do you show diagonals bisect? How could I show that this thing bisects that thing? Well, some people would say, we'll go over and find that length distance formula and show it's the same as that one with the distance formula, and then distance formula and distance formula. Oh my gosh, the distance formula is like a hardcore formula, and that'd be 4 of them. That'd be a nightmare. Let me show you an easier way. If we want to show these things bisect one another, if you could show the midpoint of AB is the same location as the midpoint of CD, then that's the easiest way to do it. It's basically 2 midpoint formulas. And if you can show this it's the same exact location, then you can show they bisect one another. So this formula right here is used when you're trying to show things bisect one another. If they both have the same midpoint, if they have the same midpoint, then they must be bisecting one another. If that midpoint is the same as that midpoint, they bisect one another. Go back up. What about showing a right angle? Does anybody remember how to show right angles? Can't really go directly, but you could show perpendicular. Do you remember from Algebra 1, what is the thing that shows that things are perpendicular? Slope, and that would be perpendicular. Remember opposite reciprocals? A slope of like 1/2, and then flip it and switch it, -2/1. I'm just using variables. So if you can show that one slope and the other slope, you got the fraction, you flipped it, and one was positive, one was negative, then that shows perpendicular. Perpendicular goes to be right angles. Let's see what else we have in here. Diagonals congruent, that could be the distance formula, things being congruent. Diagonals congruent. 2 adjacent sides are congruent. That is also the distance formula. Diagonals are perpendicular. We already said perpendicular was slope formula. Diagonals bisect angles. Oof, I have no idea how to show bisecting angles. We're not going to use that one with these proofs. Okay, now let me show you how this is going to work. But once again, let's recap on this. Parallel lines have the same slope, and perpendicular lines have opposite reciprocals. So we go over and look at this. Determine if a triangle with the following vertices is scalene, equilateral, or isosceles. Scalene means no sides congruent, equilateral means 2 sides congruent, and isosceles means, scalene means none congruent, equilateral means all congruent, and isosceles means 2 congruent. What formula do you think you are going to use to figure out if sides are congruent? Which formula? Does slope show congruence? Showed like the same length? No. How about distance? So these problems are kind of annoying. The reason they are annoying is because you have to do sometimes 3 distance formulas for one problem, which is not very fun. So let's go ahead and plot these. 0, 1. Gotcha. 4, 4. 1, 2, 3, 4. Cool. That one's 4, 4. This one was 0, 1. Let's call that A. Let's call this B. And then C is 1, 2, 3, 4, 5, 6, 7. 7, 0. 7, 0, which is C. All right, now this is how, like I said, this is time intensive. Why is this time intensive? Because we need to go over and show what the length of AB is, we need to show the length of BC, and then we have to show the length of CA. We have to show the distance between 0, 1 and 4, 4. We have to show the distance between 4, 4 and 7, 0. And we have to show the distance between 7, 0 and 0, 1. So that's 3 distance formulas. That's not that fun. x1, y1, x2, y2. Let's figure out what the distance is here. Square root of 4 minus 0 squared plus 4 minus 1 squared. Square root of 4 squared plus 3 squared. Square root of 16 plus 9. Square root of 25. This side length right here is a length of 5. Now we have to do that same process 2 more times and see if all of the sides are congruent, 2 of the sides are none of them. x1, y1, x2, y2. Square root of 7 minus 4 squared plus 0 minus 4 squared. Square root of 3 squared plus negative 4 squared. Be careful, a negative times a negative is a positive. Square root of 9 plus 16. Square root of 25. 5. So we already know 2 of the sides are 5. If the last one is, then it's equilateral. We already know it is not scaling. x1, y1, x2, y2. Square root of 0 minus 7 squared plus 1 minus 0 squared. Square root of negative 7 squared plus 1 squared. Square root of 49 plus 1. Square root of 50. Does the square root of 50 equal 5? I don't care what it is, but other than does it equal 5? No, it does not. So this, like I said, is looking at an actual figure in the coordinate plane and using different formulas that make sense for the problem. We were able to use the distance formula because we were trying to see if lengths were the same. And we found out 2 of them were the same. So that would be, that's isosceles. When you are doing this, it is important, I'm asking you guys to be lazy and efficient, okay? So if you can do a problem using 2 of an easier formula, or you can do 4 of a hard formula, do 2 of the easy formula. Let me show you what I mean by this. We already know this thing's a parallelogram, so we can skip all of the aspects of showing it's a parallelogram. To show it's a rhombus, we can either show 2 sides are congruent, 2 adjacent sides, or we can show the diagonals are perpendicular. When you're showing sides are congruent, that would be 2 distance formulas. That's one of your options. Do you want to do 2 distance formulas? Or to show diagonals are perpendicular is showing that 2 slopes are opposite reciprocal. What do you think is easier, 2 distance formulas or 2 slope formulas? It really doesn't matter. Either one will do the same thing, but just please be lazy and efficient. Personally, for me, I think slope formula is way easier. y2 minus y1 over x2 minus x1 versus the karate rabbit. Oof. So what I need to do is I have to show that the slope between B and D is an opposite reciprocal as A to C. So let's show the slope from 0, 4 to 2, 1 is an opposite reciprocal, or check if it is, from negative 2, 0 to 4, 5. Let's see what those slopes are. If one is the same as the other except for they're flipped and switched, then we know that they're perpendicular, and that would be enough to show that it's a rhombus. x1, y1, x2, y2. 1 minus 4 all over 2 minus 0. This slope is -3/2. So if the other one was positive 2/3, we would know it was a rhombus. x1, y1, x2, y2. 5 minus 0 all over 4 minus -2 gives us 5 over 6. Are those things opposite reciprocals? Nope. So are these things perpendicular? Nope. So is it a rhombus? Nope. Now once again, we were lucky because they already told us that it was a parallelogram. What's the easiest way to show it's a parallelogram? You could show this slope is the same as that and this one is the same as that. Or you can do, because that would be showing that they're parallel. Personally, for me, I think the easiest way is to show that the diagonals bisect one another. So I'd find the midpoint of this and show it's the same as the midpoint of that. In my mind, that is the easiest because midpoint formula 2 times is very quick and easy. And that would probably be the quickest way to show something's a parallelogram. So be as lazy and as efficient as you possibly can. Determine if a parallelogram with the following vertices is a rectangle. Rectangle can either be right angle or it can be diagonals or congruent. That would be two distance formulas, and this would be two slopes. Because if the slopes are opposite reciprocals, then you have perpendicular, which is a right angle. You are going to choose, do you want to do two distances or two slopes? While you're thinking, let's go ahead and plot these points. 0, 1, -1, 4, and then 2, 5. And 3, 2. Now, once again, we can either find the distance between the two diagonal points and then find the distance between the other two, or you can do the slope of a side and the slope of the other side and figure out if they're opposite reciprocals. I'm lazy. I'm going to do two slopes. Let's find the slope between 2, 5 and 3, 2. So this side. And let's see if it is an opposite reciprocal to 0, 1 slope between there and 3, 2. x1, y1, x2, y2. x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. -3 over 1. The other one would have to be flip it and switch it opposite reciprocal 1/3. Let's see if it is. y2 minus y1 over x2 minus x1. Huh. Are those things opposite reciprocals? Yep. So are these things perpendicular? Yep. So is it a right angle? Uh-huh. So is it a rectangle? Yep. There you go. All right, so like I said, we're using formulas to be able to prove things. Okay, we're going to be checking if the triangle right here is going to be a right. Figure out how do we do right. Let's plot our points. 0, 0. Then we had 2, 1. 1, 2, 1. Okay. And then we had -1, 2. Let's check. Is this thing going to be a right triangle? if you went back to that first page, how do we show things are right? Well, first, before we show they're right, we have to show that they're perpendicular. And what is the formula that helps us with perpendicular? Slope. So we're going to have to see if the slope of this side and this side are opposite reciprocals. -1, 2, going to 0, 0. Let's figure out what the slope of that is. And from 0, 0 to 2, 1. x1, y1, x2, y2. 0 minus 2, 0 minus -1. -2 over 1. So this one has a slope of -2. The other one would have to be the opposite reciprocal. x1, y1, x2, y2. 1 minus 0 all over 2 minus 0 is 1/2. Are those things opposite reciprocals? Yes. Therefore, is it perpendicular? Yes. Therefore, is that a right angle? Yes. So is it a right triangle? Yes. Okay, now let's go ahead and do this one. Okay, we're running low on time here. So we're going to figure out if this thing is a parallelogram. We're going to do that by showing that the diagonals bisect one another. This is something we haven't done yet. So we have 0, 0. We have -3, 1, 2, 3. We have 1, 2, 3, 4. -3, comma 4. And then we have 1, 2, 3, 4, 5, 6, 6, 0. 6, 0. And then we have 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, now we want to figure out if this thing is a parallelogram, and we're going to do this by seeing if the diagonals bisect one another. What was the formula that helps us with things bisecting one another? Flip back to the front page. It is which formula? Midpoint. So if the midpoint between 0, 0 and 3, 4, if the midpoint of this thing is the same location as the midpoint between -3, 4 and 6, 0, those have the same midpoint, then they bisect one another. x1, y1, x2, y2. Let's see what the midpoint of this is. Add your x's and divide by 2. Add your y's and divide by 2. That gives us 3 halves and 4 halves. 3 halves and 2. Now, if the other diagonal has the same exact midpoint, then we know that they bisect one another. x1, y1, x2, y2. -3 plus 6 divided by 2. 4 plus 0 divided by 2. 3 over 2, 4 over 2. 3 over 2, 2. Do they have the same midpoint? Yeah, then that means they must cut each other in half. All right. Okay. Now let's move on. This is the last problem. This problem says, show that it is a parallelogram by showing one pair of opposite sides is both parallel and congruent. Parallel is 2 of which formula? 2 slopes. Congruent would be 2 of what formula? Distance. I think we're kind of beating a dead horse here, meaning that we've gone over the same thing many a times. Let's just look at this really quickly. We have 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 4, 5. We had 2, 1. We have -6, 1, 2, 3, 4, 5, 6, -1. And we have -4, 3, 1, 2, 3, 4, 1, 2, 3. Now you might say, well, it doesn't look like a parallelogram. The answer is no. Well, it's just because I'm bad at drawing clearly. All right, so this one was -6, -1. I'm not going to work through this whole thing because we're already sitting at 25 minutes. What you would have done was either pick top and bottom or left and right. You would have found the slope of the, let's say we were doing top and bottom. You'd find the slope of the top and the slope of the bottom and make sure they were the same slope. You have to show they were the same slope to be parallel. If one was 5/7 and the other one was 5/7, then they are going to be parallel. And then you'd find the distance between the endpoints of the top and the endpoints of the bottom. And it doesn't matter what the number is. It could be like the square root of 67 and the square root of 67 or something. It doesn't matter if they're pretty or not. If they come out to be the same thing, remember I'm just making this number up, then that would mean that they were congruent. And congruent and parallel would be enough. These problems take a while. So I want to go back to here. I just want to remind you the most important part here. If you wanted to show things were parallel, or, well, let's say you're trying to show they were congruent, that would be the distance formula. Diagonals are congruent, that would be the distance formula. Diagonals bisect one another, midpoint formula. Showing things are parallel or perpendicular, that's the slope formula. Basically, you would be using those formulas and doing a bunch of math and checking if slopes were the same or opposite reciprocals, or if the distances were the same. All right, be lazy and efficient. Sorry that one ran a little bit long. Thanks for watching.